straws to run the night shift tonight. Once again, our data stream, recording temperatures, pressures, and all the various settings of the system every minute. This is another view inside the bottom of the combustion system, watching the fuel gasify. The steam that you see is coming out of the fuel. It's cooler than the rest of the chamber, so it flows down the fuel pile until it breaks down to hydrogen and oxygen, which then become part of the gas cloud. Hydrogen burning in combination with the other materials in the fuel produces a series of acids that we scrub out with our scrubbers. That's why we don't have the normal oxygen-based pollutants that other people have in combustion systems. You're running a hydrogen fire. Cool stuff. You're looking in to the lower half of the combustion chamber, which is on top of the gasification chamber. You see there is an arch. Gas coming up past it. On the back side of that flame, there's secondary air, which is allowing flue gas in to control the combustion. You can see at the rate, the gas is moving. It's in this chamber for about 1 second. As part of the emissions evaluation that we're running today, we're running refuse-derived fuel, which has been sorted and recycled first, then screened and ground to size, and then delivered to us. Waste to energy with absolutely no emissions issues. This is our steam turbine generator. Old and reliable. Producing power in our research unit. It's not the biggest or the baddest. Its job is to show if the power output doesn't change when we change fuel. Earlier I showed you this steam turbine for our research and development unit during startup. Right now, holding about 117 pounds steam pressure. It's producing just under 35 kilowatts of electricity. Starting at 1800 103 RPM, driving about 45 amps in the line. Fuel going into the unit, feed chute window. And assisted scrubber. Walk over to the other side of the building. These are the dust collectors for the Kitty Hawk project. The spray scrubber and wet electrostatic spray precipitator. Our steam turbine generator set. Put the turbine condenser mounted in place on this concrete pad. Our feed supply system and fuel storage for Kitty Hawk. Final stages. And the combustion system for Kitty Hawk. This is a 1.5 megawatt combustor. Standing now in the chamber that the fuel grate would be in. This is the throat of the unit going up to the combustion chamber. You can see how we've constructed this, just like the Romans did. This is the fluid cooler for Kitty Hawk. We also use it for cooling the water that's needed to condense steam and cool a scrubber in the test cell. Made by Evapco. Basically, it's a giant swamp cooler. Fans in the top, draws air up to the bottom. Behind that shroud is a large reservoir of water. It pumps up across the tubes and it cools what's inside the tubes. It's operating at full load right now. You can hear how loud it's not. This is the boiler that's going in the Kitty Hawk project. It's a Nebraska D-style boiler. It's been opened up to be a heat recovery steam generator. This is the steam turbine and generator for the Project Kitty Hawk. It's a 6,000 horsepower General Electric turbine made in the early 1940s. Served in the U.S. Navy for decades. Was salvaged and operated in a lumber mill for 20 years. Making power to drive the lumber mill and the sawmill. And when that operation closed down, thanks to the Clinton administration, we were able to buy it. But now it'll enter into another, hopefully 20 or 30 year service history with us. This is the generator. That is a 4.8 megawatt generator that has been rewound to 2.8 megawatts, driven by that turbine. 28,000 pounds and 22,000 pounds spinning together, making power. We're inside the motor control center for the Project K